Hi, good day. My name is William T. Dongo. I'm here today to give you the continuation of the lecture on climate control and refrigeration technology. The subject will be about residential and commercial heating, and then the lesson will be lesson number 3. The subject will be mechanical components inside the furnace. And then on this one we'll be talking about the mechanical components, electromechanical inside the cabinet, and then we got the electromechanical components on the air system, and then electromechanical components in the inducer. Okay, mechanical components. We'll have the pressure regulator, this one right here. Pressure regulator decreases the gas pressure supplied from the utility meter from about 7 inches of water column to 3.5 inches of water column. Maintain a constant gas pressure at the furnace. Older heating system had separate pressure regulator. Newer heating system have a combination gas valve which have the pressure regulator in one housing with the main valve. A vent opening is needed on the regulator to assure atmospheric pressure on the top of the diaphragm. On older pressure regulators, there was a copper tube that runs from the vent opening to the pilot burner. If the diaphragm was ruptured, the gas would burn off at the pilot. On newer pressure regulator, a leak limiting orifice is incorporated in the vent. To change the pressure setting on the regulator, an adjustment screw is used to set the pressure. To increase the pressure, turn the adjustment screw clockwise. To decrease the pressure, turn it counterclockwise. I can show you a picture here. One is a gas valve. One is for natural gas and one is for the LP gas. Okay, this one right here, and then this one right here. Okay. Now we'll be talking about the external manual gas valve, also known as the gas safety cock. This valve is operated when the handle is parallel to the length of the pipe and closed when the handle is perpendicular to the length of the pipe. Manual gas valves should not be used to regulate the gas supply located outside the furnace cabinet. The next one we're going to talk about will be the interior manual gas valve. Interior manual gas valves, older system have two manual gas valves. These valves were in addition to the exterior manual gas valve. The A-cock was used to turn the main gas supply on and off to the main gas valve. The B-cock was used to turn pilot gas supply on and off to the pilot. One of the several systems known as 95-5 pilot gas on the even if pilot not lit. That means pilot gas on even if pilot not lit. Pilot auto relit also use 95-5 system. And then in here is a diagram how you adjust the pressure on the regulator. You got a screwdriver on the top, and then you got the valve, and then here gas valve, and then on the other side this is the diagram too, which you got the adjusting nut on the top. Then you have this diagram here. Okay, blower squealer cage. There are two basic type. Okay, blower cage. There are two basic type. You got the belt driven and the direct drive. This is the diagram of this, the blower right here. Okay, we got one right here. Then we have this one here. And a diagram right here. Okay. We have a belt drive and a direct drive. Belt drive type is a B belt with adjustable or fixed motor pulley and fixed blower pulley. Belt drive speed adjustment is usually by varying the adjustable motor pulley diameter. That means you determine the pulley diameter of the two pulley, and then you can change the speed by calculating that differences. To increase blower speed, close the motor pulley. To decrease the speed, open the motor pulley. Found on many industrial, commercial, and older residential unit. Whenever changing blower speed, be sure to check the amperage draw of the motor. Compare your readings with the motor nameplate amperage rating. This will prevent overloading of the motor. Okay, and then we got the direct drive. The direct drive is a squirrel cage attaches directly to the motor shaft, virtually on all your residential unit and many commercial systems. Direct drive speed adjustment is accomplished by changing speed taps of the motor. And then we have the pilot line. The pilot line, okay, the pilot line is the supply tubing carries the gas to the pilot burner. Tubing is usually 1/4 aluminum and is connected with brass compression fittings on both ends. Larger system may use larger pilot lines. Note, use care to avoid cross-threading either the pilot burner or the valve when installing new pilot tubing. Okay, now we're gonna talk the electromechanical components. This one right here. First one we talk about will be the electric gas valve. Electric gas valve, which is called is the main valve. Okay. Main valve. Electric gas valve called as main gas valve. The main gas valve actually starts and stops the flow of gas up to the burner and is considered the most dangerous control on the gas furnace. There are several different types of this valve. We got the solenoid type gas valves. Solenoid valves are normally closed valves and normally used on furnaces which are separately gas pressure regulator. When the coil of the solenoid valve is energized electrically, the valves open. Solenoid valves cannot be adjusted. They are strictly open or closed valves. Okay? Solenoid valve. Then we got the solenoid valve right here. Right here. You got the solenoid on top, and then they got then here, this one is a gas valve. The same picture, this one right here is a diaphragm operated gas valve. You got another diagram here. Okay. And then we got two-stage valves. This is closed. Two-stage valves. And then this one is two-stage valves closed. And then this one is a heat motor valve. Okay. And then you got one here too. Okay. And then we got a two-stage gas valve right here. Then this is the way you're gonna reset the pilot. Okay. Mechanical diaphragm components. Okay. Mechanical diaphragm components, magnetic diaphragm valves. Two forces must be present to open the magnetic diaphragm valve. The primary force of operation is gas pressure. The secondary force is magnetic. The secondary pressure force is magnetism. When the valve is energized, on the call for heat, gas pressure and magnetism are both usually to open the valve. Neither force operate the valve without the other pressure. Okay, I showed the diagram before that. And then we got the other one is bimetal diaphragm valves. Bimetal diaphragm valves. Bimetal diaphragm valve is very similar to the magnetic diaphragm valves, except that it uses heat to operate the valve instead of magnetism. A little electric heater, normally 24 volts, is placed on or near the bimetal. When the heat on the bimetal strip is energized, the bimetal will warp and open the valve. This is what it's saying is the bimetal work is the principle works like this. You got a metal inside, and then when it's heat up, it bends. Okay? Okay. When the heater on the bimetal strip is energized, the bimetal will warp and open the valve. When the heater is de-energized, then the bimetal will cool and close the valve, because it takes time for the bimetal to heat up and cool down before the valve is operated. There will be times delay in a bimetal type of valve. Remember, time delay. The delay is in a bimetal valve is usually about 15 to 20 seconds. One disadvantage of the time delay style valves is if there is a delay ignition, there is no way to electrically shut down the main valve immediately. If delayed ignition is about to occur, shut down the gas safety cap outside the furnace cabinet. Okay? See, this is the pilot diagram that I have in here. Okay? That's the way I look like, the pilot. And then you got this one through liquid. Okay? And then the other one is a glow coil. This one right here is a glow coil type. Then the diagram is right here. Okay? This is how the pilot with the spark ignition is. Okay, heat motor valve. The heat motor valve uses the heat opening electric heating coil to move an expandable rod. The movement of the rod provides the force necessary to operate the valve. When the valve is energized, gas begins to flow through the valve in about 20 seconds. When the valve is de-energized, there is no delay of approximately 40 seconds in closing. Due to the 40 seconds delay time to close the valves, one de-energized. This type of valve is very dangerous if there is a delay ignition problem present. Okay? If delay ignition is about to occur, shut off the gas safety cock outside the furnace. Okay, and then we got the two-way stage gas valve. Two-way stage gas valve. When two-stage heating is needed, a two-stage gas valve is used normally on commercial. When the first stage is energized, the valve open to the preset low fire position. The preset low fire position is usually 50% of the normal input. The call for second stage shifts the valves from low fire to high fire at 100% input. Because of the bimetal operation, there is a 10 to 20 seconds delay between first and second stage heating. Not considered a dangerous valve even though times delay. Delay ignition is not possible because first stage is already burning. Okay, and then we got the 100% shut off automatic gas valve. This is 100% shut automatic gas valve. Okay, the 100% valve stops gas flow to the burners and pilot is in case the pilot goes out. That means 100% valve stops all gas flow to the burner and pilot in case the pilot goes out. 100% shut off gas valve are required on all LPG furnace installed indoors. After turning a three possible knob to the pilot position, depress it manually to allow gas to flow to the pilot so it can be manually lit. Once the pilot flame hits the thermocouple approximately 45 seconds, the knob can be released. The pilot flame should remain lit if thermocouple is on good condition, installed properly, pilot flame is correct, and pilot safety coil is not failed. The millivolt current actuates the internal magnetic safety unit which hold the pilot safety valve open. The pilot safety valve manual must be open before the gas will flow to the main burner. When the pilot stays lit, the knob can be turned to the on position. With the knob in the on position, the pilot gas continues to flow to the pilot and main gas can now flow to the burners. When the valve is energized electrically, if the pilot should not go out, the safety will drop out in approximately 60 seconds, closing the valve. And then the gas valve will not open again until the safety valve is reopened by lighting the pilot. Manual light 100% safety valves are used mostly on residential furnace. And then we have the 95-5 gas valve. The 95-5 gas valve is the only difference between the 100% shut-off valve and the 95-5 valves is 95-5 valve is not internal pilot safety valves. Remember, it has no internal pilot safety valve. When the knob on the valve is turned to pilot gas flow to the pilot without depressing the knob. To assure that the main gas valve does not open until the pilot is lit. A pilot safety switch is usually wired in series with the gas valves in the electrical circuit. When the knob is turned to the on position, gas will flow to the main burner whenever it is energized electrically. 95-5 valves is used on both residential and commercial application. If found on residential equipment and is defective, it must be replaced with 100% safety valve. 95-5 valves are used on commercial equipment where automatic pilot ignition is wanted. If the pilot flame goes out, gas is still flow to the pilot to reignite when the glow coil or spark ignition recycles. Operation of 100%. Now let's go back to this one right here. We got a thermocouple pilot. We talk about the thermocouple pilot. Thermocouple pilots, the thermocouple generally electrically as long as the tip is heated by the pilot flame. The 3/8 to 1/2 inch of the thermocouple should be in the pilot flame. Remember, 3/8 to 1/2 inch of the thermocouple should be in the pilot flame. The electricity generated by the thermocouple, okay, the pilot energizes the electromagnetic which hold the valve open. If the pilot flame goes out electrically, is not longer generated and close the pilot valve. The metal thermocouple is constructed of two dissimilar metal. One is tubular piece surrounding an inner solid element. The tubular piece and the inner elements are welded together at one end. The welded joint is called the hot junction because it is the point heated by the pilot flame. The outer elements of the thermocouple is braced to a copper tube. This brace joint form the cold junction. When the hot junction is heated and the cold junction remain at a lower temperature, a small DC current is generated approximately 30 millivolts. The amount of electrical energy produced is proportional to the difference in the temperature between the hot and the cold junction. The greater the temperature difference, the greater the electrical output of the thermocouple. Operation of 100% safety valves. Operation of 100% safety valves. Now that we understand both the 100% safety valves and the thermocouple, let's place the gas valve in operation. First, the reset button on the valve must be turned to the pilot position and push in. Okay? It must be pushed in. With the reset button held in, gas flow to the pilot. The reset button must be held. The pilot button must be held in for 30 to 60 seconds to heat the thermocouple. When the reset button is released, the electromagnetic hold the safety valves open, and gas can then flow to the main burner. Gas cannot flow to the main burner until the reset button on the valve is turned to the on position and the valve is energized. Okay, bimetal pilot safety. We got another one here. Bimetal pilot safety are used with the 95-5 gas valves. When the pilot is lit, the flame heats the bimetal strip, causing it to warp. The warping action causes a set of electrical contacts in series with the gas valves. Should the pilot go out, the bimetal will cool and the safety switch will open. single pole, single throw, or single pole, double throw type, depending on the pilot and how it is used in the furnace. And then you got the mercury flame sensor. Mercury flame sensor. Mercury flame sensor is used in the same application as the bimetal, except it uses a different method of closing the contacts. Instead of using the bimetal strip, a liquid filled pillar build is placed in the pilot plane. The pilot plane heat up the bulb and cause the fluid to expand. The expansion in the capillary tube exerts enough pressure to close a set of contacts that are in series with the gas valves. If the pilot goes due to the fluid contracting, okay, let me repeat my last. If the pilot goes out, the buildup cools. If the pilot goes out, the bulb cools, and the pressure in the tube decreases due to the fluid contraction. The contraction of the fluid allows the contacts to open and de-energize the gas valve. Like the thermocouple pilot, generation, and bimetal pilot, the mercury flames sensor is simply a pilot proving method. And then what we have, you got the mercury flame, and then we got to talk about the glow coil ignition. Glow coil ignition, when it is not practical to have a pilot that must be lit manually, such as on rooftop equipment, and automatic pilot ignition system is used. It is normally in the form of electric glow coil or the spark ignition system. On a glow coil ignition system, the glow coil is constructed of platinum and wound into a tight coil of wire. The coil relies on low voltage of the coil relies on the low voltage for operation, approximately 11 to 12 volts. When the pilot is blown out, current passes through the glow coil and heat is produced. As the gas passes over this hot glow coil, it is ignited. To keep from risking burnout, the glow coil cannot remain energized continuously. A pilot safety switch usually de-energizes the glow coil after the pilot ignition. And then we have the solid state spark ignition. Okay, solid state spark ignition, this one right here. Solid state spark ignition used to automatically light the pilot. Usually available for the input power of 24, 120, 208 or 230 volts. 24 volts is most common. A network of solid state components converts the supply voltage into high voltage potential at the output terminal of the module. The potential voltage is conducted to an electrode by high tension cable. The electrode is positioned on the pilot burner to provide a gap that the gas will pass through. When the device is energized, the high potential at the electrode tip will create an electric spark across the gap to the grounded surface of the pilot. The spark will continue firing until the pilot gas is open. When the solid state device detected the pilot plane, it will turn off the spark. This is accomplished because the pilot plane conducted the current to the grounded pilot. The spark will remain off as long as the pilot is lit. If the pilot plane goes out, the current flow to ground is interrupted and the spark will again jump across the gap in an airport to relight the pilot. Okay, and then the next one we'll be talking about will be the hot surface ignition. Hot surface ignition. Hot surface ignition is similar to the glow coil. Okay, the main difference is glow coil lights a pilot. An HSI takes, that means hot surface ignition takes the place of a pilot. Light the main burner. Hot surface ignition systems have electronic circuit board much like a rectification system and some simpler spark ignition system. Okay. The next one will be covering is electromechanical components in the air and the electrical mechanical components in inducer. I won't complete the lecture for this subject, so I'll make another lecture as another section will be that will cover these two subjects over here. I think this one has been too much, it's long, and I will stop the lecture for this section. So this will be section A, that's lesson 3A, and the next one I'll make these two right here as a lesson 3B. I thank you for watching this video, and I hope so you learn a lot of information about it, and then okay, thank you very much.